Hello everyone. In the previous lecture we have studied on the physical and index properties of a soil. Today I'm going to introduce you to the soil compaction as another geotechnical properties, and we will understand the compaction characteristics of a soil. In the outline of my lecture, I will go through the theory of compaction, covering the definition, objectives, standard test method, as well as briefly on the influencing parameters, and in the next week I will explain in more detail about those parameters as well as compaction in the field. So let's start with the question, what is compaction? Well, by definition, compaction refers to a process in which that we push the soil particles into a denser configuration by removing the air voids between the soil particles and applying the mechanical energy. So as you can see, initially the volumes of voids between the particles are quite large, but by adding some amount of water and applying mechanical energy, we will be able to have a more dense and more compact soil. The fundamental of soil compaction is relatively new in comparison with the soil mechanics history. Basically, the principle of compaction has developed in early 1930s by Proctor, and that is why the standard test method is called Proctor test for his honor. But why we need to have the soil compaction? So basically, as we all know, soil is being used in many projects as construction material. However, in some cases, the natural state of soil is not sufficient to be used as a structural field. Therefore, we need to somehow improve it. One of the effective and conventional methods for the improvement is compaction. So basically, the main objective is improving the engineering properties of a soil. As a result of compaction, we expect to have less post-construction settlement, as well as increasing the load-bearing capacity of a soil. At the same time, we will reduce the hydraulic conductivity of a soil, because as you can see in this figure, by doing the compaction, the volume of voids decreases. That's why the permeability of the soil specimen will be reduced. The other objective of the compaction is increasing the stability of the slopes by having more interlocking between the soil particles. And we can control the undesirable volume changes as a result of compaction. So how we can find the compaction characteristics of a soil in the laboratory? As I said, Proctor test is the procedure to find the compaction curve. By doing the test, we will find the two main parameters of the soil. One is the maximum dry density, and the other one is the optimum moisture content. There are two standards for this test. One is called standard Proctor, and the other one is the modified Proctor. So basically, the main difference between these two tests is the total energy that we applied on the specimen. For the standard, we applied around 600 kilojoules per square meter of the specimen, while in the modified one, it is around 2700 kilojoules. This one is the compaction mode. The volume of the compaction mode is around 1 liter, and the rammer, for example, for the standard Proctor, the weight of the rammer is 2.7 kilograms, while for the modified one is around 5 kilograms. So this is the procedure how the test is carried out in the laboratory. Initially, we weigh the empty mode, and then we attach the collar to be able to compact the specimen in different layers. Then we mix the soil with some amount of the water, and then we compact the specimen depending whether it is a standard Proctor or modified one. And at the end, we measure the weight of the wet mass compacted inside the mold. The difference between figure 4 and 1 will give you the mass of the wet soil inside the mold. So basically, if you use the phase relations equations, as I said last week, you will be able to find the wet density, because you have the total weight of the soil, the wet one, and the volume of the mold. And once you find the moisture content of the specimen, you will be able to find the dry density using this equation. So basically, you have find one point of compaction curve for that particular moisture content. So if you plot the dry density over water content, you have 1 point. But we need to repeat the test for at least another 4 times with different initial moisture content, so you will be able to find the compaction curve. So by having the compaction curve, the peak point is called the maximum dry density, and the water content corresponding to that point is called optimum moisture content, because that moisture content is where you can reach the maximum dry density for that particular compactive effort or energy. There is a 0 8 word lines on this plot that shows the density corresponding to different water content where there is no air voids inside the specimen. Practically, it is impossible to reach that state, because perhaps you will have some amount of voids inside the specimen. But you need to make sure that all the points, all the compaction test results should lie under the 0 8 void lines. Otherwise, there is a problem in your procedure or in your calculation. So what factors are affecting on the soil compaction? Here is the list of the parameters. Today I will talk about the moisture content, and in the next week for other parameters such as a specific gravity of solid grains, as well as the energy that you applied on the specimen and the type of the soil, about in terms of the gradation, clay minerals, and etc. So how the moisture content is affecting the density? As you saw earlier, by increasing the moisture content, you have initially increasing the dry density, but after that you have a reduction. So basically why it is happening, assume that you have a very dry specimen, for example around these points. The friction forces between the particles are quite large, and that's why it's very difficult to compact a specimen. So therefore you have less dry density. But by adding some amount of the water will create a film around the particles, and it acts as a lubricant. So the particles can easily rotate and rearrange in a denser configuration. That's why the dry density increases. But it continues until reaching the peak point. And after that, further increase into the moisture content will result in a reduction of the dry density, because the water starts to replace the soil particles in the specimen, and since the density of the water is much lower than the density of the soil grains, you will have a reduction in the dry density. It is expected that at the peak point, you have the most compacted configuration of the grains for that particular energy, and you have a good strength and stiffness as well as low permeability. So to summarize, today we have gone through the theory of compaction. We covered the definition, objectives, describing the standard test method, and I explained about the effect of water on the soil compaction. And in the next week, we will continue for other parameters, influencing parameters, as well as compaction in the field. So if you have any questions, let me know. Otherwise, thank you for your attention.